way different from the others. So let's do one single example. Look at this situation. The speed of 8 to the 10 to the 6 meters per second on x-axis. The magnetic field of the Earth has a magnitude of 0.05 millitesla, and is directed at an angle 60 degrees at the x-axis, lying in blah blah. That will be the magnetic force. So it should be easy, like to plug in. We have all the elements. It's first of all, it's electron. The charge of electron is 1.610 to the minus 19. You guys need to memorize it. I recommend you never forget it. If you're doing anything regarding to engineering, that number should be always remembered. The velocity is given. The magnetic field is given. The angle also is given. It's the 60 degrees between the direction of the velocity and magnetic field, right? If you put all the plugs in, it's 5.5 10 to the minus 17. Let me know if I have any questions about this. Should be easy for you, right? So this cross things and all the stuff that I was telling you is like this guy in and out. So if you see a bunch of dots in the book, a bunch of crosses, now you know what it means. Is that clear? Awesome. So the question that you asked, like here, so see what happens like this guy. Imagine we're going to start with this. Make sure everybody following this. So forget about all the other stuff like this guy and this guy. Let's focus on this. We have a magnetic field, area of magnetic field, this green cross, right? And we send this charge, positive charge, inside the magnetic field, and it moves in this direction. Are we cool? The force is upward. Anybody has a question about this? Why the force is upward? Do the right-hand rule. V is to the right. Magnetic field into the page. So the force should be upward, right? So force pushes it upward. Okay. So it toward the center. That's what we're going to get. So instead of going in this direction, it's going to divert it a little high. But when it moves to the point a little higher, so that's a trick about the force. It always changes. It doesn't stay in only one direction because it changes the velocity change, force changes, etc., etc. So what happens if we send a charge inside the magnetic field, we start to do this circular funny motion, always. If it's positive charge, it goes like this. If a negative charge, it's going to be anti-clockwise, right? It's going to be clockwise. So this is anti-clockwise, it's going to be the clockwise. So again, let's see if anybody has any problem with this. So it pushes up, it goes a little up, and now the direction is this. So the force, the velocity is this, but now the force is here. So it pushes this a little higher. Again, a little higher, again, 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 again. So don't, like here, it goes a little up, up, up. It all the times, there's gonna be feeling force toward the center, all the time. So magnetic force always gonna push it toward the center, or keep it on this leash of circular motion. We want to study this and see what's the behavior of electric charge inside the magnetic field, because it never stops. It starts to move. So it goes up, left, right, whatever, it depends on this law that I mentioned. So is that clear for everybody? Any question why it's just circulating? Don't feel shy or anything. I'm here just to explain this. So if you have any question, let me know, okay? So we cool? So this happens. Let's just see if we can analyze this motion. So we have a force. This is our old friend, right? The second law. Is that right? The second law is telling us what's going on. There's going to be magnetic force This guy is a charge, has a mass of m, so it's getting accelerated. This has acceleration. Even if the velocity is constant, it has acceleration. Why? Why it has acceleration? Why?
Change in direction.
Changing the direction. So because it changes the direction, it always has this acceleration, which, as we know from general physics 1,